David Saltman, CEO of Malama Composite. David and I have go back quite a while, and truly David is a pioneer and in the vanguard of bioproducts. He's passionate about bioproducts, green chemistries, and over the years have been involved in many, many exciting things, including commercializing and selling products. Today he's going to talk about some of the recent work that he's doing at Malama Composites related to various building and construction as well as entertainment industries. David, you're on next.
Thanks very much, Bima. It's a pleasure to be here, and thanks to OBIC Bioproducts Innovation Center. We very much appreciate it. That little picture you see of me there is actually sitting on a lounge made out of our new materials, out of our biofoams. It's hand-shaped by surfers. It's surfaced in biobased resins and epoxy from entropy resin, and so this is part of the real world of trying to take these chemistries and these materials into the real world, I guess. First slide, please. Slide, please. So our company is Malama Composites, actually means to care for and protect in Hawaiian. That image you see, our logo, is the kuru, which is an unfolding fern leaf, and it's their symbol of the regenerative power of nature. So that's where we get our inspiration. Next slide, please. We develop and manufacture rigid urethane foams. We make these out of bio-based polyols. It is not 100% materials. We still rely on MDI for our A side of the formula, but our B side is very green, and it really gives us and our customers the ability to produce lightweight, very strong, less toxic, cost-competitive products that are much more sustainable in every regard. And we've made all kinds of things with these rigid urethane foams, from wind turbine blades, surfboards, and catamaran hulls, and now really entering the world of green homes and buildings. Next slide, please. The competition, I think most of us know, urethane foams bring together two sides, an isocyanate material. That comes together with a polyol. It's highly reactive. It foams up and then cross-links to form a cross-linked polymer that we know as a rigid foam. Our materials are about 95% closed-cell foams, so these aren't open-celled soft foams. These are hard materials. In the case of our competition, they use entirely petroleum-based materials, and as a result, oftentimes these materials are toxic. They're almost impossible to do anything with once they're used. Next slide, please. Our materials rely on a methylene-based isocyanate. It's a non-toxic material. It has no off-gassing, and we combine that with polyols from soy or castor, jatropha, and most recently algae to create non-toxic materials. So our factory generates no air or water pollution, and the material, zero-emission materials, you have no off-gassing, and are entirely recyclable or biodegradable at the end of their useful life. Next slide. And just in terms of the advantages of these materials, really it gives us very high performance features, so high bending and shear strength, so you get durable products. Urethane foams are well known for their R value, their insulation value, so high moisture resistance, really enabling us to get into the whole world of insulating cars, homes, appliances. These are common areas where you'll find urethane foams, and we simply create urethane foams that are a greener form of that. I mentioned that they are low-cost materials. We have to be price competitive with existing products in order to be successful in the marketplace. And finally, these are carbon-negative materials. So every pound of our foam, actually according to a study that was done by NIST on behalf of the U.S. Department of Agriculture, every pound of our foam sequesters over 2.5 pounds of CO2. slide, please. If we look at the industry realistically, you can see by this chart that by far the vast majority of polyurethane foams go into the building and construction industry, about 72% of it. But appliances, insulated appliances, things like washers and dryers, and certainly refrigerators use a lot of core foam, as does the transportation industry for its insulation value, both acoustic insulation and temperature value. Packaging, where we're doing a lot of work. And finally, industrial design, where these foams can be shaped and surfaced for all kinds of applications. And I'll get into that in a second. When we began this company, we're 3 years old. We chose to establish our intellectual property and our brand through some niche markets. And that really enabled us to get into business, generate some cash flow, and really start to understand chemistry in a mass manufacturing environment. Next slide. So to do that, we actually chose the entertainment industry, and that's because this industry uses a lot of foams to shape and sculpt movie sets. So you see a picture there of the Titanic. That was a scale model that James Cameron built down on the set in Mexico in a huge pool, 2 million pounds of foam. Incredible Hulk at Universal Studios, all built of foam and then surfaced in epoxy. Next slide, please. The problem, I don't know why these slides were messed up in terms of their some of the words, but I'll try to fill in what's missing. The industry itself uses a foam called trimer, which has pentane gas as its blowing agent. So when these workers shape that foam, they're actually being exposed to a toxic gas which is emitted from the foam. And they've complained about it for years. We came along, we developed a castor-based foam called Studio Biofoam, and it's just gotten unbelievable response from that industry. We've also found that Studio Biofoam has applications for things like knee braces now and prosthetics, where they shape our foams, in this case using CNC milling machines. They replicate someone's custom knee, exactly copy of their knee, build a knee brace or a prosthetic around that sculpture, and then throw away the foam. So the foam is actually just used in tool and die process, but again, posing no problems in the workplace in terms of off-gassing or work exposure. Next slide. The second foam we're working on right now is called Flow, and it's actually a pour foam for the surfboard and paddleboard industry. Obviously, this industry uses a lot of foam. Its real problem is that it's still using toluene-based foams, and TDI, toluene diisocyanate, is a B1 carcinogen. So you can imagine these workers, that's a picture of Rusty Preisendorfer, who makes Rusty surfboards in his of mine, working on his entire life, hand shaping these beautiful boards, but being exposed to toluene as he does, and that's absorbed by the skin as well as inhaled. So we have created an entirely water-blown, using MDI and a recycled polyol, which we think is going to be very good for this industry. Next slide. And then we've also created a packaging foam called Fill. And the packaging industry, insulated packaging industry, is an interesting one to us. It's very large. It's over $500 million of opportunity in the U.S. alone. And what this is the pharmaceutical industry and biotech industries ship reagents or vaccines or even organs all over the world, and those boxes have to stay cold inside. So they essentially pour a box of foam inside a cardboard box, and we've developed a material which works very well for that, has very high insulation value and high impact strength, so that these very expensive packages that they carry, the reagents or the chemicals, won't be damaged in shipping. Next slide, please. So this year year is sort of our big launch year, I would say, for a brand new set of materials. We, as I said earlier, you can see by that pie chart that the largest industry for us really is the building and construction industry. And that, for us, represents on so many levels the real purpose of our mission. Because our homes and buildings around the world utilize about 60% of our resources on Earth, and they generate about 40% of our greenhouse gas emissions, and that's in heating and cooling of those homes and buildings. So if we can make higher performing, higher insulated green homes, really made a significant contribution on a global level. Next slide, please. And so in this picture, what you're seeing are structural insulated panels using our foam surfaced, in the case of the left-hand picture, with oriented strand board. In the right hand, it's surfaced in cementitious material, panelized building systems. And our first project is actually on the Ivory Coast. I've just received the purchase order for that. And we're going to be building up 10,000 small homes, all pre-panelized, using our foam surfaced with geocomposite materials, geocomposites being made out of a cementitious material. And we're very, very excited about, our advent into that industry. And we're using a material called Inocore, which is a fire-rated, highly insulative product we're launching this year. Next slide. We see all kinds of market drivers. There's obviously U.S. Green Building Council's LEED program is focused on energy efficiency and also on resources, renewable resources, and indoor air quality. EPA's environmentally preferred purchasing program. We're right now fighting with the USDA. Some of you on this call can help me out here, because on the bio-preferred program, even though we are the highest bio-rigid urethane foam on the market today, we fall underneath their required 25% threshold. So I'm going to be doing some lobbying here in the not too distant future to make sure that we can wear a USDA bio-certified product logo as well. And then the Department of Energy has obviously a program which very strongly incentivizes energy efficiency in homes and indoor air quality. And so you can see that from the outside world as well, we're really being pulled into the market of building materials. Next slide. And that really brings us to a notion of creating a brand new building system that stick frame homes and cement block homes really are in the Stone Age. Our building methodologies are primitive relative to other industries. If you look at the revolution that has happened, say, in the electronics industry enabled by polysilicon materials, or in the transportation industry motivated by composites. And yet in the building industry, we really are in the dark ages. It's high time that our homes be as smart as our foams. And so we're creating something called a CASA, which is Advanced Composite Building Systems, combining our urethane foams with light gauge steel internal framing, exterior geocomposite, to make very high energy efficient, high performance, but very low cost homes. Next slide. And so what we're doing, this is just a little illustration of the steel framing that's embedded in our foams, surfaced to create structural insulated panels that lock together. And these have insulation values 2 to 3 times that of our current homes and buildings. So really strong. And by the way, mass is not your friend in an earthquake. We take out the mass in a home, and it becomes much more wind and earthquake resistant as well. And these homes are waterproof. So in floodplains, in an age of global weirding and warming, I think that these types of homes built on the east coast of the U.S. or in floodplains will be very important in the future. And that's just a picture of sort of our ability to take that fundamental, the building system, and treat it any way we want to treat it. So any way the architect wants to specify that, any type of geographic challenges we may have to meet, budget parameters we have to meet, we think we can do it using this sort of kit of parts. Think Legos. We really are building using a systematized approach to prefabricated homes. Next slide, please. And this is a picture of one of the smaller homes that we're building. So when people think low-cost housing, they think boxes or concrete bunkers. These will be beautiful, modern homes, some of them as small as 585 square feet, all the way up to 100 square feet, and then up to 3-story building structures. So not only homes, but also schools, residential, retail space, multi-unit dwellings, churches, medical centers, etc. will be responsible for all that using this same building system. Next slide. I think we just went over that, so it's just an example of a multi-unit dwelling. So this then brings us to the idea that instead of looking at our system as simply a home, think of it as a community. And integrating solar and wind energy, integrating communication services right into these foam panels, so building methodologies, LED lighting, water collection on the rooftops, community gardens, and sustainable strategies. And our idea is not to ship these analyzed from here. Our real concept for these all-composite, biocomposite homes, if you will, is to be able to put a factory in close proximity to where we're going to be building these communities, and then utilize local labor and local materials, blow our foam there, roll form steel on site, create the geocomposite materials on site using local aggregates, but our formulas, and be able to deliver entire communities. Next slide. So that's it for today. That's a summary of what Malama Composites is up to utilizing these new bio-based materials. Thanks very much.
Thank you very much, David. Great presentation. A lot of interesting things going on. Thank you again. I'm sure you'll have a lot of questions at the end of the here. Now, moving on to our second speaker, heard about the use of